Okay. Looks like this is working now. Let's do all of this. I'm not sure why that just happened. Come on. Are we still recording? Looks like it. Volume's good. Okay, let's see what happens. Now, I'm going to run through this, then I'm going to run that limit work, okay? First and second period, my calc classes, gang. What happened? The testing was today, so I had to handle the kids, so I didn't do anything. All right. So, for this one, I'm hoping you're thinking, if you did this, it says use a calculator, but we can do this one by hand, so let's go ahead and do it by hand. It'll look like this. If anything pops up that you're like, what? That's not good for tomorrow, so let me know. These are both getting distributed into here, into here. And that's going to turn this into, and I should really give myself some more room, but I'm not. 11 minus 2x minus 1 over x minus 6 and an 11 and a 2x minus 1. Are you okay with that?
Yeah.
Cool.
It's going to be 1 over x minus 6.
Well, that top,
It can't be.
to save some room, so that 11 minus 2x minus 1 is really 11 minus 2x plus 1, right? So that's really 12 minus 2x, which is really negative 2 times x minus 6. And that's the x minus 6 we're looking for. Okay? That's when the x minus 6 cross out for us. That's super sweet. And you plug in 6, and you get negative 2 over 11 times 11, which is 121. So that's how we handle the fraction dudes. Okay. B, I told you, again, we're moving a little quick here, just because I want to get through this whole thing. If you have questions, though, let me know, and I'll explain. But B, we can't do this by hand at this point. I'll show you how to do this later on by hand. But all you really do is go to Desmos and graph that thing. I'm not even going to do it. If you graph this on Desmos, I promise you it looks like this. 1, 2, 3. It comes in like this and goes right. There's a hole here, which you can't see. It does that. All right. That y value there is 5/2, where that hole is. So the answer to this is 5/2. All right. Again, do that graphically. We're not going to have that tomorrow on the retake of the old quiz. So don't worry about that. All right. But you should be able to look at a graph and tell me the limit. Okay. That's what this is. Oh, I think we did this yesterday. As x approaches 2, that's here and here. That's headed to 2. Okay? As x approaches 0, that's the left side and the right side. That's headed to 6. All right? As we approach 6 from the right, here's 6 right here. From the right side, that is headed to negative infinity. As we approach 5, well, this side's going here, and this side's going here. We can obviously see that's a jump discontinuity. That's a DNE. As we approach negative 2 from the right, here's negative 2. Here's the right side of that. That's headed to 2. As we approach 6, that's DNE, because the left side is headed to negative infinity, and the right side is headed to positive infinity. All right? And thank you. And as we approach negative 2, that's also DNE. There's a jump discontinuity there. The right side's headed to 2. The left side is headed to negative 3. And as we approach 5 from the right, that's 5 headed right here. That's the right side of that. That is 1. Okay? Good? All right. Oh, yeah. Guys, I'm not going to make you graph one of these. I'm going to have limit questions about this, but we can do this. Yes, we can, like Bob the Builder style. When you drop 0 into here, you get 4. That's an open circle. It's got a slope of -1/2, so it's going to go like this. If you had to graph it, it would look like that, dude. That's less than 0. Cool. Between 0 and 4, at 0, this is 0, so that puts a point there because it's got an equal bar on it right there. Plug a 4 and you get 8, so it's going to be way up here. Right here, right? Boom. And that looks like this. All right, I'm just connecting the dots, basically, it's a line. and greater than 4. Put 4 into there and we get 1. That's going to be an open circle. Badoom. And it's just a parabola. You can plug in 5, you're going to get 2. You can plug in 6, you're going to get 5. Cool. So it's a parabola going up like this. That's what that looks like. I know, right? Tomorrow the question will be about limits, though. So you can see the limit does not exist at 0 or 4 because those are jump discontinuities. All right. When you come down to this question, oh no, my OneNote is frozen. Come on, OneNote. Don't be a butt. I'm on best performance too. We'll shut that down. Is it still recording? Looks like it is. There we go. You guys know where that is? It sure is a beach. That's at St. John in the U.S. Virgin Islands. That's Maho Bay. You should go there. Okay. I'm asking, does the limit as x approaches 2 exist? You can graph it if you want. You don't have to. Because this thing splits at 2, the left-hand limit, as we approach 2 from the left, is this function. So that's x less than 2. You just plug 2 into it. I can't make it any easier. When you plug 2 into there, you get a 2. Right? Right. The right-hand limit, when you plug 2 into that, boom, is 10 minus 8. That's also 2. So these are equal. Because the left-hand limit and the right-hand limit are both 2, you're going to say yes. Everyone clear on how to answer that? You're not going to write any words. You're going to say the left-hand limit equals the right-hand limit in that fashion. If they don't equal each other, you're going to say they're not equal to each other with a little crossbar like that. Okay, but these happen to be equal to each other. Great. Now we got this guy moving right along. As we approach -1 is one of my splits. It has a left side and a right side. The left side, because I'm asking about -1, I need to check both of those. This one at -1 is -1, right? So the left-hand limit at -1 is -1. All right? The right-hand limit, though, has to deal with this function right here. The right-hand limit, as x approaches -1, happens to be, when you put -1 in there, you get 1 minus 3, that's -2. Those are not equal. So this is D and E. Okay? As we approach 1, 1 is not one of the splits. 1 is entirely on this interval. At 1, this function equals 4. That's what it approaches. So that is it. Okay? Good talk. At 3, 3 is one of the splits. The limit as we approach 3 has to do, this is the left side of that. When you put 3 into there, you get 18. Okay? You can write it out if you want. You don't have to. But the limit as we approach 3 from the left is 18. That's because of that function. The limit as we approach 3 from the right, look at my scribble scrabble handwriting. That's this function. That's also 18. It doesn't matter if the 5 is there. That's just where the point is. Yeah, because they both approach 18. Oh, this answer is 18. Questions on that? We're feeling yes? Again, super sweet if y'all get 100% on this quiz tomorrow. That'd make me super happy. Very easy to grade. Okay? Unless you're cheating, that's bad. Don't do that. But 100%, what we're shooting for. All right, as we approach 4, we're on this interval. When you put 4 into here, you get 48 minus 12. That's 36. Okay? So here's what we know. It's easy to graph this thing and see what's going on. Here's what we just did. We said, at -1, the right-hand side goes to -1, or the left-hand side, I mean. Boom. But the right-hand side is -2. Can we handle that? That's a jump. So it's not continuous at x equals -1. There's a jump. At 3, 1, 2, 3, this goes to, pretend that's 18 up here. This goes to 18. Whoa. The point happens to be at 5, though, because that's this equals 2 bar right here. But the other side goes to 18 and comes out of there. So x equals 3 is a hold. Okay? And there's only 4 practice limits down in here. You'll see stuff like this tomorrow, but I'll probably give you 6 or 7 like I did on the first thing. Okay? So there can be synthetic division and all that stuff. There's none on this. As we approach 2, I'm hoping this makes sense for everybody. Look how we're going to write this. This is x minus 2, x minus 3. That's how that factors. So this is the same thing as that. That's negative 1. Easy enough? Good talk. This is a complex fraction. We're going to multiply it by the denominators we don't want. That's going to turn it into 5 minus x over x minus 5 times 5x. Aha! Those cancel out, leaving a negative 1 in its place. When you put negative, or when you put 5 in there, you get negative 1 25th. This is a square root. When you plug in, you get 0 over 0. We don't want those square roots there, so we're going to multiply by root x plus 2. Boom, boom. That's going to make this a squared minus b squared over x minus 4 times root x plus 2. And we're headed to 4. Those cancel out, leaving a 1, so it's 1 over 4. Okay. And last but not least, d, when you plug 3 into there, you get 6 over 0. That's not 0 over 0. That means we don't need to cancel anything out here. That means there's a vertical asymptote. We check both sides. Boom, boom, boom. Here's 3. There's my vertical asymptote. We plug in 2. When you put 2 into that, you get 4 minus 3. That's 1. Am I doing that right? Yes. Over 2 minus 3. That's negative 1. That's down here. That means this side's going down. Cool. When you plug in 4, look how good we are. You get 16 minus 3. That's 13 over positive 1. That's 13. That's up here. That means this side's doing this. This is B and E. Ta-da! What's up?
Letter C.
What up? Okay, let's shut this down.